Hi everyone, today we're doing notes for lesson 4.2, solving systems of linear equations using tables and graphs. When two or more equations share the same variables, we call it a system of equations. When we solve a system of equations, we are looking for the point or points the equations have in common. Those common points, x, y, are the solutions to the system. So for our first example, given the system 2x plus 2y equals 300 and x equals 4y, we have to determine which of the following are solutions to the system. So we're going to do this by plugging our point into the equations, and if it is true for both of the equations, then it's a solution to the system. So for our first one, remember 100 is our x, 50 is our y. So we have 2 times 100 plus 2 times 50 equals 300. So that's 200 plus 100 equals 300. Well, that gives us 300 equals 300. So that's true. So let's try the second equation. It's x equals 4y. So 100 equals 4 times 50. 100 equals 4 times 50 gives us 200. So this one is not true. So this is not a solution. Let's try the next one. 2 times 40 plus 2 times 10 equals 300. 2 times 40 gives us 80 plus 2 times 10 is 20 equals 300. 80 plus 20 is 100. That does not equal 300, so we can actually stop right there. We know if it's not a solution to the first equation, it's not going to be a solution to the system, so you do not need to plug it into the second equation. All right, let's try our last one. This time my x is 120, my y is 30, so I have 2 times 120 plus 2 times 30 equals 300. That's 240 plus 60 equals 300. And 240 plus 60 is 300. So 300 equals 300, which is true. Let's plug it into the next equation. X, so 120, equals 4 times y, which is 30. 120 equals 120. So yes, this one, 120 comma 30, that's the only one that is a solution to the system. There are 3 types of solutions to linear systems of equations. When you aren't given a solution to the system of equations, you need to solve for it. When you solve a system of equations, there are 3 types of possible answers. Number 1 is one solution, where there's a point of intersection x comma y. When there's no solution, the lines do not intersect. And the last option is if there's infinitely many solutions where you have the lines are exactly the same. Okay, so we're going to think about the graphs of 2 lines in the coordinate plane, and there are 3 cases that this can happen. So like we said, the lines intersect. When we're looking at these lines and they intersect, what's true of the slopes is that the slopes are different. What will be the solution to the system? It's going to be the point right here where they intersect, x comma y. So it's one point, x comma y. All right. If the lines are parallel, then they will never intersect. So what's true of the slopes is that the slopes are the same, but the graphs have different y-intercepts. What will the solution to the system be? There actually is no solution here because the lines never touch. The last case is where the lines coincide. If you look carefully, there are 2 lines here. And what's true of the slopes, we have the slopes are the same. And in this case, you also have the same y-intercept. And what will the solution to the system be? This is going to be infinitely many solutions. So it's all along the line. Okay? In this unit, we're going to discuss 4 ways to solve a system of 2 linear equations and 2 variables. We have a table method, where it involves making an input-output table. A graphing method, this involves graphing each of the equations in the system. Then we're going to have a substitution method. This involves substituting the value of one variable from one equation into the value of that same variable in the other equation to get one equation in one variable. And then the elimination method, which involves adding equal quantities from each of the 2 equations together to eliminate one of the variables and end up with one equation in one variable. So first we're going to look at solving using a table. So we're going to write each equation in slope-intercept form and then complete a table to find a solution that satisfies both equations. So solve each system of equations using a table. For A, both of these are already in slope-intercept form, so we can plug in the x value to find the y. So for the first one, if I do 4, I'm going to blow this up so I can write it small. If I do 4 times 0 minus 3, that's going to give us 0 minus 3, which is negative 3. I'm going to do 4 times 1 minus 3. So that's 4 minus 3, which gives us 1. 4 times 2 minus 3, so 8 minus 3 gives us 5. 4 times 3 minus 3, well, 12 minus 3 gives us 9. And 4 times 4 minus 3, which is 16 minus 3, which gives us 13. Okay, let's do the next one. Here I have negative 2 times 0 plus 15. So that's going to give us 0 plus 15, which is 15. Negative 2 times 1 plus 15. So negative 2 plus 15, which is 13. 2 times 2, negative 2 times 2 plus 15. So negative 4 plus 15, which is 11. Negative 2 times 3 plus 15. Negative 6 plus 15 gives us 9. And negative 2 times 4 plus 15, which is negative 8 plus 15, which is 7. So looking at my tables here, if I want to find the solution, I can see this one. For 3, we get the same output, so my solution is 3, 9. For our next one, we need to write these in slope-intercept form. So I'm going to do the work up here. So we have negative, I'm going to pull this up a little bigger. We have negative 2x plus y equals negative 1. We're going to add 2x, and this gives us y equals 2x minus 1. So that's our first one in slope-intercept form. Let's find the other one in slope-intercept form, and then we'll do the 2 tables. So here I have y equals 5 times x plus 2 minus 2. So first we have to distribute. Y equals 5x plus 10 minus 2. Then we do 10 minus 2, and we get y equals 5x plus 8. Okay, so now we have our 2 equations. Now, I didn't give you x's and y's here, so let's start with the easiest number to plug in. Let's do 0. So we'll plug 0 into each of these. So if I plug 0 into the first one, I have 2 times 0 minus 1. So 0 minus 1, that gives us negative 1. For the next one, if I have 5 times 0 plus 8, 0 plus 8 gives us 8. All right, let's try 1. So we have 2 times 1 minus 1. 2 minus 1 gives us 1. Here I have 5 times 1 plus 8. 5 plus 8 is 13. Now, if you notice, both of these are increasing, and it seems that they're getting further apart. So maybe we should try some negative numbers. Let's do negative 1. So now I have 2 times negative 1 minus 1. Negative 2 minus 1 gives us negative 3. Here we have 5 times negative 1 plus 8. Negative 5 plus 8 gives us 3. So we're getting closer together. Let's keep going in the negative direction. If we do negative 2, 2 times negative 2 minus 1, negative 4 minus 1 is negative 5. 5 times negative 2 plus 8, negative 10 plus 8 is negative 2. We're getting a lot closer. We'll do negative 3 next. And 2 times negative 3 minus 1, negative 6 minus 1 is negative 7. 5 times negative 3 plus 8, negative 15 plus 8 is negative 7. And now we can see we found it. So at negative 3, they both have an output of negative 7, so our solution is negative 3, negative 7. You can also use your TI graphing calculator or Desmos to solve systems using the table feature. So it says use technology to solve the following systems. So first, we have to solve for y in each equation. So here I'm going to subtract 3x. I have 2y equals negative 3x plus 15. Divide everything by 2. Y equals negative 3 halves x plus, this is 15 halves. Our next one, y equals, this is 1 half plus 2x. I'm going to rewrite it as 2x plus 1 half. So it says enter into technology and find the point in common. So let's go to Desmos. And our first graph, we had y equals negative 3 halves x plus 15 halves. Our second graph, we had y equals 2x plus 1 half. And so when we look at our graph on Desmos, it says that we want to use the table feature doing this. Now we can actually see our coordinate or our point of intersection, but let's use the table feature. So if we go to the wheel, we can actually remember hit copy. So I'm going to copy each of these. And then in the second one, I'm going to hit table. And I'm going to do the same thing for this one. Hit table. And now I can take a look at this. And if I look at my two tables, I can see that at 2, 4.5, I have a point for each of them, which is this point on the graph. So again, we can see 2, 4.5 is going to be our solution. So let's record that. Okay, we're also going to talk about solving by graphing. So we're going to solve each of these by graphing. It says we can use our graphing calculator or Desmos to solve by graphing. We're going to sketch the graphs below. We're going to draw these by hand, and then I'll show you how we can check it on Desmos. So for the first one, we need to get this first equation into slope-intercept form. So I'm going to rewrite it up here. 2y equals 3x plus 8. We're going to divide everything by 2. And that gives us y equals 3/2 x plus 4. All right, so I'm going to graph this first one in the blue. So we're going to go up 4, and then we're going to rise 3, run 2. Rise 3, run 2. You can also go down 3, left 2. That's our first line. Our second one, I'm going to do in red. So here our y-intercept is -5, so we start by going down 5. Then we're going to do our slope of 3/2. So we rise 3, run 2. Rise 3, run 2. You can also go down 3, left 2. And then connect to make our line. Now this one, you may have noticed that our slopes are both 3/2, right? Which tells us that these are going to be parallel and that there's going to be no solution. But it's always good to verify by graphing, and we were asked to graph here. All right, for our next one, we have y equals 1/2 x plus 4 and y equals 4/3 x minus 1. So let's do this first one in blue. So I'm going to go up 4, then we go up 1, right 2. And down 1, left 2. Our next equation, I'll do this one in red. This time we have 4/3 x minus 1. So we start by going to -1 for the y-intercept. Then we rise 4, run 3. Oops, I counted off there. Sorry. Up 1, 2, 3, 4, 1, 2, 3. Go. And then we can also go down 4, left 3. And so we can see our solution is the point right here, which is 6, 7. And again, I'll show you how you can verify this using Desmos. Clear out these graphs we had. So if I enter the equations, we have y equals 1/2 x plus 4, and then y equals 4/3 x minus 1. And then if we just tap the point there, we can see the intersection point is 6, 7, as we had found. All right, the last one here, we have our first equation is in slope-intercept form. The second one we need to solve for, though, so let's do that first. 3y minus 6x equals -3. So I'm going to add 6x. Then we have 3y equals 6x minus 3, divide by 3. And we get y equals 2x minus 1. All right, so let's graph these. We can see our first graph is y equals 2x minus 1. Our second graph is also y equals 2x minus 1. So that tells us we're going to end up with the same line, but let's still graph it. So we go down 1, and then we go up 2, right 1. And we repeat that. And draw our line. Our second graph, we're going to do the same thing. So we go down 1, and then we go up 2, right 1, and we know it's going to coincide and be the same line. So this one will give us infinitely many solutions. And the solutions are all of the points along y equals 2x minus 1, because it's all the points along that line. Okay, so I'm also going to show you how to do this on Desmos. The nice thing about when you're doing the graphs on Desmos is we can actually use the original equations. So we have y equals 2x minus 1. And for our second one, I'm going to graph the original equation, 3y minus 6x equals negative 3. And you can see it ends up being exactly the same line. It graphed it on top. It gave us points for both. So any one of these points that they give us, right, are going to be solutions to both of the equation. That's why they give you a bunch of points. These are some nicer ones down here. But again, all those points on the line are the infinitely many solutions to the system. And that's where we're stopping today.